Okay, so now we're going to go over number 1 through 9. Just as a reminder here, yeah, it's okay. So we're going to go over 1 through 9 here. And most of these are either going to deal with that's the eraser. P1 V1 over T1 equals P2 V2 over T2, or PV equals nRT. So one of those two formulas. Okay. For P1 V1 over T1, the only thing we need to keep in mind is that temperature needs to be in Kelvin. Okay. That doesn't matter what pressure and volume are in, as long as they are consistent. So the pressure in the beginning has to be the pressure in the end. Volume in the beginning has to be the volume in the same. Volume in the end. They have to be the same. Okay. But however, if we use PV equals nRT, pressure has to be in ATM. Volume has to be in liters. N is moles. R is a constant. T has to be in Kelvin. Okay. So just keep that in mind. When you do take the quiz, you might want to have all that information readily available for you. Okay. So every time I attack one of these problems, I always do the same thing. And even when we did 10 through 14, I really should have done it this way too, but I kind of rushed through them. So number 1 says here, gas at a constant temperature, so we're going to ignore temperature, occupies a volume, so the volume is 2.4 liters, and exerts a pressure, so pressure 1 is 710 mmHg. And then what volume, so we want to know V2, will it be if it occupies at a pressure of 75 millimeters of mercury? So pressure 2 is 75 mmHg. So it does help to write all this stuff out. And then we know temperature is constant. So we just have P1 V1 equals P2 V2. That's it. So 710 times 2.4 equals V2, which we don't know. I should have wrote P first, but it doesn't matter. And 75. So we're solving for V2, so we divide both sides by 75. Divide by 75. Okay, cancel those out. So it's 710 times 2.4. Use my calculator here. 710 times 2.4 divided by 75. And I get the new volume to be 22.72. And just make sure we use liters in the beginning, so it's going to be liters in the end. That's the answer. Okay. Next, number 2. Number 2, what pressure? So number 2, we're looking for what pressure of a gas that originally occupies, so the original volume is 3.5 liters, and the original pressure is 248 mmHg. We want to know the new pressure if now the volume is increased to 6.43 liters. And we're holding temperature constant. Okay, so another kind of easy one here. So P1 V1 equals P2 V2. Our units are the same. Our pressure is going to be in millimeters of mercury. Okay, so P1 is 248. V1 is 3.5. P2 we don't know. And V2 is 6.43. Okay. Then we're solving for P2, so divide by 6.43. Divide by 6.43. P2 equals, and when you do the math there, I'm just going to make sure I did it right. 248. I have to clear my calculator first. 248 times 3.5 divided by 6.43. And I get 135. And then it's going to be the same units that we had before, so it's mmHg. Look at that, I got the same answer. Okay, next one. So I am recording this, so if I'm going too fast, you can always go back and watch it. but do feel free to stop me and ask a question if you like. Number 3, at a constant temperature. Oh man, all these constant temperatures. It's too easy. Constant temperature, gas exerted a pressure of 1.44 atm and occupies a volume of 1.58 liters. It's compressed until the pressure, the new pressure, is 6.29 atm. What is the new volume? So again, P1V1 equals P2V2. 1.44 times 1.58 equals 6.29 times V2. Solve for V2. Divide by 6.29. Divide by 6.29. We get doing the math here, 1.44 times 1.58 divided by 6.29. And I got V2 to equal 0.36. And the units originally were liters, so it's that many liters. Okay. Number 4. Gas at a constant pressure. So this time pressure is constant. So pressure is constant. It's going to be V1 over T1 equals V2 over T2. Well, I don't know that for sure, but that's what I'm guessing. Okay. It occupies a volume of 0.4 liters at its original temperature of 50 Celsius. And then what will the new volume be if now the temperature is 300 Celsius? So don't forget, we have to convert to Kelvin. This is the only time we always have to convert to Kelvin. Not the only time, we always have to convert to Kelvin. So add 273. Add 273. This one's easy. This one's 573. I guess this one's easy too. 323. Okay. So that's our new temperature. Okay, then V1 over T1 is 0.4 over 323. That equals V2 over 573. Okay, for this one, I'm just not, you could do cross multiply and solve. I'm just going to multiply both sides by 573. Makes it easier, for me at least. So multiply by 573 on both sides. These will cancel, but if you do it to one side, you got to do it to the other. So don't forget that. Always do it to both sides. So 573 times 0.4 divided by 323. And you get the volume to equal 0.71. And the volume was in liters, so it's liters. Wonderful. I got the same answer. It's always good when I get the same answer that's in the answer key. Okay, next one. Number 5. So number 5 says a gas occupies a volume of 0.105 liters at a temperature of 105 Kelvin. What Celsius temperature? So we want to know the new temperature. Will its volume be at 0.14 liters? So they asked for the temperature in Celsius. Just remember that we can't use the formula in Celsius. So the last thing we're going to do is convert it to Celsius. We're going to get the temperature in Kelvin, then we're going to convert it to Celsius. There's a problem like this on the quiz, and all the time I get people answering it, giving me the temperature in Kelvin. And you just have to read the question carefully. A lot of people don't read the questions carefully. Okay, make sure you're answering what the question is asking. Okay, so here V1 is 0.105, T1 is 105, V2 is 0.14, and T2 is what we're solving for. Now, because T2 is on the bottom, I like to do cross multiplication here, cross multiply. So 0.105 times T2 is equal to the other two multiplied by each other. So 105 times 0.14. Anytime it's on the bottom, I like to do cross multiplication. Much easier. Okay. And then I got to solve for T2, so divide by 0.105. That cancels, but if we do it to one side, we got to do it to the other. 0.105. So T2 equals, now remember our answer here is going to be in Kelvin, but the question asks for it in Celsius. So 105 times 0.14 divided by 0.105, and I get T2 equals 140. That's in Kelvin though. They want it in Celsius, so we got to subtract 273. So minus 273, and I get negative 133 degrees Celsius. So tricky. Okay. Tricky. Okay, I'm going to erase everything actually. Okay, next problem, number 6. It says at 75 degrees Celsius, the temperature one is 75 degrees Celsius. A gas has a volume of 3.22 liters. What volume will it occupy, V2, at 75K? So temperature 2 is 75K. Okay, so we do have to convert this Celsius to Kelvin here, so add 273. And it's going to be, again, V1 over T1 equals V2 over T2. Okay, pressure is held constant here. Pressure is held constant. Okay. Now, V1 is 3.22. T1 is that 273 plus 75, so that's 348 Kelvin. V2 is what we're trying to solve for, and T2 is 75. Okay. Again, we got to solve for V2, so multiply both sides by 75. 75. So V2, so that cancels. V2 equals all this mess here, 75 times 3.22 divided by 348. So you get 0.7 basically. All right, 0.69. And then our volume, it was in liters here, so it's liters here. 0.69 liters. Okay, next one. Okay, number 7. 7 says a gas at 300K, so original temperature is 300K. Occupies 6.5 liters, so the volume originally is 6.50 liters. And a pressure, so the original pressure is 355 mmHg. What will its new pressure be? So we want to know new pressure. Be at a temperature of 250K. And a volume of 4.80 liters. Oh, they were so nice. They gave us Kelvin temperature. We don't have to convert anything. So this one is the whole combined gas law. P1 V1 over T1 equals P2 V2 over T2. Okay, so P1 is 355. V1 is 6.5. And then T1 is 300. And then P2, we don't know. We're solving for that. V2 is 4.8. 0. And then T2 is 250. Really, all these have 3 sig figs, so our answer should be in 3 sig figs, but I'm not count. I don't really count that. Okay, so we gotta get P2 by itself. So I'm going to get rid of these two things. So do the opposite, 250 over 4.8. Those will cancel. However, if you do it to one side, you gotta do it to the other. So 250 and 4.80. Okay, so let's see here. 250 times 355 times 6.5 divided by 4.8 divided by 300. P2 equals 400 mmHg. We're at 401, really. This is, there's too many decimals there. It should only be 3 sig figs, but whatever. Okay, so that's the pressure. Okay, next. Two more. We got 2 more. Number 8. So at 120 degrees Celsius, so T1, 120 degrees Celsius, a gas exerts a pressure, so pressure 1 is 212 mmHg. When its volume is 0.496 liters. If the temperature is now raised to 240 Celsius, what volume will the gas exert a pressure? That's weirdly worded. So what volume, we're looking for volume, if the pressure is 183 mmHg. Okay, so let's convert the temperatures, add 273, add 273. I don't have enough room if I'm not going to write it. I'm just going to write it in the equation. So pressure 1 is 212. Volume 1 is 0.496. And temperature 1 is 393. That's just these added together. Okay. And that equals P2, which is 183, times V2, which we don't know, over the new temperature of this one, so that's 513. Okay, we're going to solve for V2, so 513, 183. Get rid of them. Do the same to the other side, 513, 183. And we'll get our answer. 513 times 212 times 0.496 divided by 183 divided by 393. And our new volume is 0.75 liters. And then it was in liters, so it's going to stay in liters. Whew. That was fast. Did I get it wrong? You got 750. The only thing I can think of is that one of these numbers, you made it a decimal. Let me try one more time, make sure I did it right, but I'm pretty sure it's 513 times 212 times 0.496 divided by 183 divided by 393. Yeah. If you got 750, did you make this milliliters? If that's in milliliter, if you use 496 milliliters, then you'll get 750. Because this is equal to 750 milliliters. Okay. You maybe just missed the decimal point when you plugged it in the calculator. Could have happened. Yeah. Okay. Last one. Number 9. Okay, so number 9 says the gas is confined to, so the volume 1 is 515 milliliters. The pressure 1 is 107 mmHg. And the temperature 1 is 38.6 degrees Celsius. Okay, and then the new volume. The new volume is 644 milliliters. The new pressure is 635.7 millimeters mercury, so 35.7. And we want to know what is the new temperature. And they want to know it in Celsius, but we can't use Celsius in the equation, so we have to convert to Kelvin first. We're going to get our answer in Kelvin and then subtract 273. Okay, so P1, 107, V1, 515. T1 is, I'm going to do this one on my calculator because it's too hard to do it in my head. 38.6 plus 273 is 311.6. And then P2 is 635.7. V2 is 644. And it's milliliters, so we're good. And then T2 is what we're solving for. Okay, because the variable's on the bottom here, that's when I like to do the cross multiplication. So now we have T2 times 107 times 515, and that's equal to 311.6 times 635.7 times 644. Okay, and then divide both sides to get rid of this. So 107 and 515. Well, if we do it to this side, we got to do it to this side. 107, 515. Okay, so let's do that math. 311.6 times 6. My handwriting's so awful. 635.7 times 644 divided by 107 divided by 515. Yep. And we get our temperature to be 2,315, but that's Kelvin. Okay, that's in Kelvin. We want it in Celsius. The answer they want is in Celsius. Okay, so we're going to take that and we're just going to subtract 273. So minus 273. And I got 2042. Close enough. 2042 and 2043 are close enough. Just be careful again. We're going to get our answer in Kelvin, but they asked for it in Celsius. You have to read the question carefully. Read the question carefully. Now, I've done these like a million times, and I have lots of practice with these. And I've done these specific ones like probably like 10 times. So I know what I'm looking for, but you may have to take a little bit more time to read the question carefully. Okay, so make sure you read the question carefully. Okay, so that's it. We're done with that. I'm going to stop the video.